We didn't find the hottest place on Earth by walking there. We found it by looking down from orbit. This map shows surface temperature data collected by NASA satellites. Look closely at this thermal anomaly in Iran's Lut Desert, a recorded maximum surface temperature of 70.7 degrees Celsius. When researchers applied newer software models in 2021, that number jumped even higher, hitting 80.8 degrees. But reading a measurement collected from the cold vacuum of space is entirely different from feeling it. Satellites map the thermal radiation of a desert floor effortlessly, but they can't tell you what happens to human biology when it actually tries to stand on an 80-degree surface. To test those satellite readings on the ground, an expedition traveled directly into the lowest point of the Lut Desert, a specific basin known as Gondam Daryan. This terrain is a massive expanse of dark, jagged volcanic rock. Its physical features resemble the surface of an alien planet. The question is, what actually occurs when modern technology and the human body itself are forced to operate at the absolute thermal ceiling of our planet? Arriving at this basin at noon reveals a vast, canyon-like geography, marked by towering sand formations and deep carved valleys. This cross-section highlights the first major problem for anyone standing down there. The area sits at a very low elevation, meaning descending hot air sinks into the basin, hits the valley floor, and gets trapped by the surrounding ridges. Any natural cooling circulation is blocked. Factor in what that trapped air sits on: kilometers of dark volcanic basalt rock. Instead of reflecting solar radiation, this basalt acts as a thermal sponge, aggressively absorbing it and radiating heat straight back up into the stagnant air. This creates a stark divide between the air and the ground. A meter above the surface, in the shade, the air temperature sits around 54 degrees Celsius. But the physical rock directly absorbing the sun reaches well over 70 degrees. Hyper-absorbent rock baking under direct sunlight, covered by a heavy blanket of trapped air. The landscape functions as a localized thermal feedback loop, a geological oven. Inside that oven, standard engineering quickly fails. Pointing a heavy-duty infrared thermometer directly at the ground causes the internal mechanisms to max out and completely freeze in the heat. A backup laser thermometer doesn't last much longer. After exactly 2 minutes of exposure to the ambient air, the screen throws an error code before the entire device shuts down. The metal of the camera equipment begins acting as a heat sink. It absorbs so much ambient energy from the air and the radiating ground that holding it bare-handed for more than 3 seconds burns the skin. Thick gloves become mandatory just to press record. If you set a smartphone on one of those rocks, the plastic housing around the edges actually begins to warp and melt from the contact. Standard electronics are built to function in predictable environments, but when those microprocessors and industrial plastics meet 70-degree ground heat, they simply collapse. It is easy to replace a melted phone, but the human body relies on strict internal temperature regulation to survive. And here, even with constant hydration, those biological cooling systems start to falter. The wind blowing through the desert mimics an industrial hairdryer. Because the air is so intensely hot and dry, sweat evaporates off the skin instantly. The body loses water rapidly without getting any of the intended cooling effects. The 70-degree ground physically transfers its heat straight up through your footwear. Walking across the basalt, standard thick rubber boot soles soften and lose structural integrity as they press into the boiling rocks. A human being cannot slowly adapt to this environment. Operating in this zone places an immediate, rapidly expiring time limit on your biology before fatal heat stroke sets in. As the sun begins to set, the air temperature drops to roughly 45 degrees Celsius, still punishing, but survivable enough to allow for a broader survey of the area. For years, the prevailing belief about Gandambarian was simple: an environment with Mars-like soil temperatures and zero surface water must be a completely sterile, lifeless zone. But walking through the hottest part of the basin proves that assumption wrong. The expedition team found a praying mantis actively moving across the rocks, right next to the dried remains of a grasshopper. Hidden in the shadows of the boulders, entirely functional micro-ecosystems exist here. The basin supports specialized insects, resilient desert reptiles, and small desert foxes. These creatures possess highly specific, evolved biological mechanisms that allow them to exploit the absolute margins of this furnace. They endure and navigate daily temperatures that reliably destroy our most advanced recording equipment. It took less than an hour for the desert to shatter laser thermometers, melt phone casings, and overheat cameras. Yet native biology remains intact. When an environment is hostile enough to liquefy rubber but still supports an active food chain of insects and predators, our baseline understanding of habitability has to change. Gandam-Berrien proves that life can find a foothold in conditions that are otherwise hostile to industrial-age engineering. Human presence here is temporary, measured in minutes by our technology and our biology. But for the species evolved for the loot, 70 degrees isn't an endurance test, it's their home.